All right, I just want to go through some commentary on some of these slides. Again, this is just the PowerPoint that you downloaded and are working through currently. So use it to hear a little bit more about some of the questions that you're working on, and if you got stuck, for sure check out the ones you got stuck on. So the warm-up, I feel is fairly straightforward. Just remember, you need to be able to use the formulas. You don't necessarily have to have them memorized. So in order to use the formulas, just knowing the radius and the degree of the sector that we're talking about. All right, so there are the answers to the warm-up as you already had access to. Again, just making sure that you are correctly plugging in those values and calculating correctly. Okay. These two questions, finding the volume and the surface area of each shape. So the cylinder is fairly straightforward. Volume of cylinder, volume of a curved surface of a cylinder. You have those two formulas given to you on your formula sheet. Those are fairly straightforward. Again, making sure that you are correctly typing in your calculations. The volume of the surface area part of this, rather, do make sure that you calculate the volume of both the top and the bottom. And that's what that 2, the green 2, and then the pi r squared, that's what that represents. It's 2 of those areas, the top and bottom of the cylinder. Again, always round to 3 sig figs or the exact answer. The unrounded values that you see on your screen, just remember these are not the exact answer. Those are decimals that are cut off on your calculator that would go on and on and on. So make sure you are stating your final answer to 3 sig figs. All right, this one is a little trickier than maybe what it seems, and it has to do with the base of the pyramid is not a square. So that really throws in some tougher parts that maybe you didn't realize at first. So let's go through this one. Volume. Volume is still fairly straightforward. It's the area of the base times the height times 1/3. So that's fairly straightforward. Again, in the formula on your formula sheet, it says h is the vertical height, and that is given to us of this pyramid. So that vertical height there, that is a given. So we know what that is, and volume, and then to 3 sig figs. There we go, 4.60 centimeters cubed. Do make sure you label correctly with the correct units for volume, surface area, and just regular old distance, or length rather. The second part of this, the surface area part, if you think about the net of this shape, you have the area of the base, which is the square, so that's easy to calculate. But then you have the 4 triangular parts. But again, the issue is that the area of the base, or sorry, the size of the base, they're not square. So we have kind of 2 sets of triangles to calculate. And in order to calculate those, we have a little bit of work to do. Because in order to calculate the area of a triangle, we generally want to know the height of that triangle. We know the base, but we don't know the height. If we were to know some other information about these triangles, that would be helpful, but we don't, right? So we need to know these heights, and the ones that are purple and the ones that are green will be the same. So if I find one, then I know the other for the greens, same for the purples. So I'm just going to label those as X and Y's, and those are the things I need to solve for. And so just to kind of put this back on the original shape, if you notice over here, the purple one corresponds to that face, and the green one corresponds to that face. So as we're setting these up, it's always a good idea to draw a step-out triangle separated from the image that you're working with, and label the information we know. So for the green, the distance, so the 2.9, that is the height of the pyramid, right? That is the vertical height of the pyramid. And that's the same for the other triangle we're going to set up here. The 2.9 is the same on both, but it's the 1.4 on the green one. The 1.4 here comes from, that is the half the distance, right? Half the distance of the 2.8. So that half distance would come from the middle of the base there, right? Or on the 3D shape, the middle of the base out to the side there. Okay, and then for the green, or sorry, for the purple, the 0.85 comes from taking half of 1.7, right? Would be this distance and this distance. So then here's what we need to do. We need to use a little Pythagorean theorem, right? So Pythagorean theorem would allow us to solve for both of those. Those are both the hypotenuse of each of those respective triangles. So we can easily then calculate the hypotenuse of each of those triangles, right? These are right triangles, even though they're not marked. These are right triangles. So then our final calculation here, it's doozy. We've got, get rid of some of that, the area of the base, that's the 2.8 times 1.7, that's the rectangular base. And then the two triangles, the two pairs of triangles, so the green and the purple pair, right? And I just put the x and the y variable in there just to represent that decimal, but you would actually need to plug in the unrounded value there for the x, right? The x and the y here. And then when you do that and type that all in carefully, whether you do it piece by piece or all at once, we do have our answer. We have our answer 18.696, so on, so on. Final answer 18.7 centimeters cubed. This one, the log, right? So we can kind of treat this like a cylinder. So you notice that we're going to set up a volume of a cylinder calculation. This would be representing before the log is cut, before that wedge is cut. And so when you plug that in and you end up with 532 point so on, that's the volume of the full cylinder, but we want to know just the volume of the log that's left. So the wedge is cut out, and you see this next calculation here. This next calculation is this fraction is simply the fraction of the circle that's left. So if you just focus on the end of the log, right? So the end of the log, the fraction of the circle that's left is the 310 degrees, right? So 310 degrees over 360, that's the fraction of the circle that we want to calculate. So that's why we're using that fraction and not 50 over 360. So that might have been the confusing thing in this, the working that is shown here. Final answer, 458 meters cubed is the volume of that log with the wedge removed. Here we have another triangle question, or pyramid question rather. Again, notice on this one that the base has dimensions of 8 and 5. So again, it is not a square base, which always makes things a little trickier, especially when we're looking at surface area sometimes. So the other thing to keep in mind is draw a step out triangle whenever possible. It's always a good idea to draw a step out triangle. For this first one, we're trying to find find the size of the angle, right? So find the size of the angle between the edge BE and the base ABDC of the pyramid. So BE is this edge here, and the base would be the whole rectangular base. So generally what you're going to end up doing is drawing a step out triangle where, so this line here represents the base, the plane of the base. And so just drawing that out separately, labeling it, and then thinking about what information we know the 10 here. And it appears that we don't quite know this, right? This length here, but in the process here, we can actually calculate that. So that's one of the first things. So tangent of angle EBO. So this right here is the angle we're trying to solve for. We have OE, which is 10, which I labeled. And then OB is actually, we can calculate that using Pythagorean theorem within the base, the rectangular base. So you'll notice here, this calculation right here, OB, is actually coming from using this right triangle within the face, the same plane as the base. So this right triangle has a side of 8. One of the legs is 8, the other one is 5, and then the hypotenuse would be the total length CB. So then when we divide that in 2, right, divided by 2, we end up with just the length OB. So this down here, this length, square root of 89 over 2, is that length of OB. So that is what we want to use in our calculation, not the decimal, right? Use that whole calculation. So this would be something that you'd want to put in parentheses if you're trying to type that all in at once. And then notice we're solving for an angle. So inverse tangent of that whole mess gets us 64.7 to 3 sig figs. If you did not get that, but you think you typed it in right, check your calculator and make sure you are in degree mode. The next part, again, we're still finding an angle size, right? So all of these are, we're finding an angle size between the edges EB and EC. Between the edges EB, so EB is here. Remember, we now know that value from a previous calculation. So EB and EC is over here. So again, always drawing a triangle, step out triangle is usually helpful. Marking the angle we're solving for between EB and EC, though this is the angle. And we know this is O, right? That's the middle, right? So we just drew this triangle here. You can see it in the shape, but then separated. Again, some things we know would be, this would be a right triangle here and there. And so think about that. We can then say, okay, so the angle BEC, the total angle we're finding would be equal to doubling angle BEO. And since we already know a little bit of information about BEO, that triangle, that's the part of the triangle we'd want to focus on. So we already, from the previous part, we already kind of know a little bit more information about this, and we can use that to help us solve, right? So we know we already solved for the measure of angle B in that previous question, or EBO. And so they're taking 180 minus 90 plus that angle from the previous part. And that gets us this angle, angle BEO. And so then we double it and we get 50.5. Last one, part C here, calculating EMO. These 3 types of calculations, these are all very typical type questions that you would need to feel comfortable figuring out given a pyramid like this. These types of calculations, the angles in the different places that they're asking you to find the angles, and so on. So that's the triangle. EMO is the angle, right? So again, like I'd said before, not sure why I drew it backwards. Let's try that again. So EMO, this is the angle we're finding. And they do tell us that M is the midpoint of AC. So again, we know that that just comes straight out from O to side AC, right? So there are some different things we could do here. In this case, we can we can use, let's see, so OE, right? So we have OE and OM. So we know those, right? So, okay. So we know those 2 values, right, in our triangle. This is 10, this is 4. And we can find by taking the tangent. So tangent of that angle we're finding is equal to 10 over 4, but we're finding an angle, so we're taking the inverse tangent. Okay, inverse tangent of 10 over 4 gets us 68.2 to 3 sig figs. The volume then, again, is fairly straightforward. It's 1/3 times the area of the base times the height. Right? So, excuse me, there's the volume formula that's on your formula sheet. this would be an example of an exact answer, right? So 400 over 3, that is fine, right? Leave it as the exact answer. The decimal to 3 sig figs would be fine too. Okay. Again, as you're working through some of these, just make sure that you understand what you're being asked to find, right? So this one kind of lay out a plan for you. So find the total volume of the cylinder. So once we know total volume, we also need to know the volume of one cube that is to be made. And then once we know those two things, we can calculate the number of cubes simply by dividing, right? Dividing the total volume by the volume of one cube. So we want to make sure we're dividing volume. So that's the rest of this work. We end up with 34 cubes. All right, we can't make 35 because we don't have enough, right? You got to round down, and that's what rounding would have told you anyway. But just in the context, you got to think about appropriate rounding. You can't make 35 cubes if you don't quite have enough material for that 35th cube. And last one here, again, this one is fairly straightforward, just solving for a different piece of information in the formula, solving for h, given the volume and the radius. Okay. So hopefully this helps. Again, make sure you're working to understand these as best you can, bring questions to next class period, and make sure you get help as you need it.